Hi, hello friends, welcome to the today's session. In this session, we are going to discuss about a supernetting concept which mainly used in public IP assignment done by ISPs. So what is a supernetting? How it is helpful in configuration of IP addresses? So supernetting is mainly used in class C networks, how it is to be done, and what are the advantages with supernet we are going to discuss in this session. Before entering into the session, we'll say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Myself is Srinivasrao Sir, having more than 15 years of experience in the GATE stream. I taught in many premium academies with a high success rate. Many of my students are alumni of IIT, NIT, and central universities. So, my dear friends, you also can be in that, such that you can be a postgraduate from IITs and NITs just by cracking the GATE examination, which can be done by the proper professional training. This training you're going to get by India's topmost academy, none other than Unacademy. I also had industry experience as a data admin as well as system analyst with a good certifications. So certifications also will help you in your career. So there are two kinds of subscriptions in an academy. One is a 12 months, the other one 24 months. You can opt any subscription. 12-month subscription well fit for current fourth year students, and 24-month subscription the third, second and first year student can opt. So my dear friends, you start your GATE training since start of your first semester itself. So that means all the 10 core subjects are involved in the GATE program. So once you take the subscription in an academy, you're going to have unrestricted access. That means you can able to use live lectures as well as interactive sessions by the faculty members, doubt sessions, and one is to one's guidance program. An academy also launched the Iconic Batch, which is a purely for one is to one student guidance program, which consists of plus courses too. So, my dear friends, why to do late? Immediately get the admission in an academy and enjoy the benefits and the curriculum and the course contents which are there in an academy. Especially, you're going to get like quizzes as well as mock test because mock test is going to change your confidence levels. So that's why all kinds of materials are available in an academy. Apart from that, if you like to take the admission, you can also get the discount benefits. So just by using my referral code. So use my referral code and enjoy the benefits which are given by an academy. So let's crack GATE CSC is our YouTube channel. All the YouTube lessons you can able to get it through this. This is our broadcast channel. So subscribe an academy and use my referral code to get the discount benefits. Hit the bell icon for latest notifications and updates. Well friends, now I'm going to start what is a supernetting. So last session we discussed about a subnetting concept. So that means when you talk about the IP addressing, you're having a two parts, two level hierarchy and a three level hierarchy. So my dear friends, two level hierarchy consists of network ID and host ID. Three level hierarchy consists of network part and host part. Apart from that, either you may have subnet ID or you may have a supernet ID. So my dear friends, we already discussed about two-level hierarchy in our previous lectures, which consist of how to identify NID and HID. We also learned the concept of a subnet, how to do subnetting in different classes like C, B, and A. And we also learned that how to obtain subnet IDs and subnet broadcast address. So in this session, we are going to learn a new topic called supernetting. So the idea of supernetting is nothing but what? A group of networks we are trying to aggregate. Please see the difference between subnet and supernet. In subnet, you see that one network is going to split into multiple networks. That is a top-bottom approach. When you do supernet, a small networks are being combined together to form a larger network. That is the concept of bottom-up approach. It is the concept of super network. So my dear friends, subnet is different from your supernets. Again, I am repeating, so subnet is nothing but a large network is going to split into smaller networks. Supernet is nothing but smaller networks are being combined together to form a larger network. Why? Why to do a supernetting apart from or rather than subnetting? We learned the advantages of subnetting, my dear friends, but there is a disadvantage in subnetting. What is that? As many parts you did or as many subnets you did, then you see that every subnet is going to wastage of HIDs because of block number and because of subnet broadcast address. Please observe, friends. One is because of subnet ID and the other one because of subnet broadcast address. So subnetting is going to do as many subnets you did, you're going to have these two are supposed to be reserved. For example, if you are taking a, for example, class C network divide into 8 subnets. I'm talking about its drawbacks, negative share, but positive share subnetting is wonderful. And class C network divides into 8 subnets. Therefore, you observe how the hosts are being segregated. So when you are talking about the class C network, you see that the maximum number of HIDs you may get 256 we know, because the class C is nothing but triple N dot HID concept. Therefore, this 256 is divided into 8 parts. So friends, each part is going to get 32 HIDs. But you see, in that 32 HIDs, you cannot use 32. Every subnetwork cannot use 32 because 2 are reserved. Why they are reserved? Because of, I said that, block number, that is a subnet number or a subnet ID, and the second one, subnet broadcast address. So friends, let me show you how the wastage is going to happen. I said that 8 subnets. Then you see that the wastage of HIDs are 8 subnets, and each subnet is going to take 2 reserved IPs. Then therefore you are seeing that 16 IPs you are going to have. And that means your host number of hosts are being decreased. So out of 256 HIDs, 16 is already wasted Hence, you can able to use only 240 HIDs. So, what is the criteria here? If your subnets are increased, this is your total pool of addresses. Total pool of IP addresses they are. You see that if subnets are increased, that means I am doing several parts to make our decisions easier. If subnets are increased, then automatically the host IDs, the wastage of host IDs are also going to be increased. So wastage of HIDs are also going to be increased. That's why we are not going to do this kind of approach, especially in internet IP assignment, which is done by ISPs. So what the SuperNet is saying, instead of wasting 2 HIDs in your splitted networks, -2 we are wasting here, -2 we are wasting here, -2 we are wasting here, and -2 we are wasting here. Instead of that, the super network, a large India's super network, that's what is nothing but what? India's large super network. It is under the control of Ministry of Communication. What they do, they see that they are trying to combine all the smaller networks. So I say I'm merging subnet 1 or network 1. We will call it as a small network. This is a network 1. I'm also going to do another small network aggregation. I'm also do another small network aggregation. So when you do aggregation like this, then you see that each class C network, when I am saying a small network is nothing but it is a class C network, then by doing aggregation, the advantage is nothing but the super network is going to have all the host IDs which are there in your smaller networks. So friends, your class C network can give you 2 power h, 2 power 8 and 2 power 8 and 2 power 8. So when I combine them, when I aggregate them, you're going to get a larger super network which consists of 2 power 32 minus 2 HIDs. This is the advantage with your supernet concept. So my dear friends, and now we are going to see that how you could able to do supernetting and how you can able to assign the IP addresses to the nodes. That means what is the range of IP addresses once you constructed supernet block, and every supernet is going to be identified by supernet ID, and as well as you can say that supernet broadcast address. So our idea is, so instead of writing 2 power 8 and 2 power 8 and 2 power 8 and 2 power 8, we want to merge them. So my dear friends, how you can able to do this merging concept? So here you are going to have 256 HIDs, and here you are going to have 256 HIDs, and here you are going to have 256 HIDs, here you are going to have 256 HIDs. So my dear friends, by combining them, we are going to achieve 4 different networks subnet host IDs are together pooled. So you can able to have this larger network can able to satisfy that 4 into 256 HIDs it is going to achieve. So almost all it is equivalent to 1000 host IDs. Now my question is, can you generate 1000 HIDs from class C network? This is our question. Can you generate 1000 HIDs from small, because class C is very small network. small class C network? Question mark. It's not possible. Why it is not possible? We know the class C, the class C can give you a maximum of 2 power 8 HIDs only, which is nothing but 256 HIDs. So now you decide how you could able to achieve your objective, that is 1000 HIDs I want to get. Yes, this is a make it possible. You can make it a possible using a concept of supernetting. Possible by doing supernetting. So as I told you, how many small networks need to be combined? This is another very important. So how many small networks to be combined? How many small networks to combine? Which is very simple. We want to see that 1000 HIDs I want. So keep 1000 HIDs in log base 2 form so that it is going to tell you that how many HIDs bits you require. So I need 1000 HIDs are nothing but what? I need 10 bits HID format. So when you are having a 10 bits HID format, I need to say that now we are trying to borrow from your network ID. So don't get confused, friends. Observe carefully. So what I am going to do, you see that class C network when you talk the class C network, it is a triple N and a H. This H consists of 8 zeros. As like this, as there are 8 zeros, it can give you 256 HIDs only. So now I need 10 bits, 0 bits. How could you get this? Then we are trying to borrow from your next octet. So borrowing is the concept of borrowing bits from NID is the concept of supernetting, and masking the HID parts is concept of subnetting. Please understand, friends. Get the difference between subnetting and supernetting. Borrowing bits from NID is a concept of supernet. Masking HID position bits is a concept called subnets. So subnet is doing, I want to mask in the HID part, not in the NID part. But supernet is telling you that I'm not going to do any kind of masking from zeros to ones from your HID. It is saying that I want to do masking from your NID. That means subnetting is masking zeros to ones of your HID, but supernetting is a masking ones to zeros in your network ID. Again, I am repeating, friends. When you talk subnetting, it's nothing but what? Masking HID bits from zeros to ones of subnet mask. This is the rule you must not forget. So its main intention to target on your HID position only. When you are talking a supernet, it is a completely reverse opposite. What is that? Masking. So here also we are going to do masking only, but masking your NID bits. So I'm going to say that masking NID bits from NID means one positions only, 1 to zeros, because we want to see that zeros to be increased because host ID is mainly referencing zeros only, zeros of subnet mask. Here also we are going to use a subnet mask. There also we are going to use a subnet mask. But this subnet mask is masking HID part, But here we are doing a masking on NID part. So how you could do subnetting, I will show you. Now you see friends, for example, I am giving you class C mask. So class C mask is telling you 255.255.1234567 8. Now you observe carefully. This is your default mask. If I am doing some manipulation here, so I say that this becomes 1 and this becomes 1 because this is your HID part, we know. And if this becomes 1, this is how I am doing a subnetting. What is the meaning of subnetting? If you manipulate on your HID from zeros to ones, it is subnetting only. But what the supernet is saying, I am taking example here. I say class B mask, class C mask I am giving you. With the 255, we know that this is a NID, this is a NID, this is NID in class C. Here also this is NID and 255, this is NID, and this is also 1, 2, 3, 4, 5, 6, 7, 8 because NID 255 means all 8 ones are there. Here also all 8 ones, here also all 8 ones. Now your HID, our target is that 1, 2, 3, 4, 5, 6, 7, 8. This is your default mask. Now what the supernetting is saying? The supernetting is saying that we are not going to disturb HID part because we want to acquire more number of zeros. So what I am doing? I am trying to borrow 1 or 2 bits from your next octet. So your next octet is the before octet of your HID is nothing but what? Third octet, which is representing net ID only. But we are asking the third octet to give 1 or 2 bits or any number of bits, I don't mind, so that based on my requirement I am going to borrow. What is your requirement? 1000 IP addresses our requirement. So I am borrow this and I am masking this to 0. Now after that I will ask one more time borrow because I got only 9 zeros, 10 zeros I want. This is also going to be masked and it becomes 00. So my dear friends, what is your new mask? Your new mask after supernetting. We already learned the new mask after subnetting. Now the new mask after supernetting. We are not performed any kind of operation on HID. The operation is performed on your third octet only. So therefore first octet is not disturbed. Second octet is also not disturbed. Last octet is default with 0. Now this octet got disturbed. I did 2 bits supernetting. Therefore the 6 bits are there with you and 2 are 0 bits. So 6 bits are nothing but it is 252. See the beauty of this. So now my dear friends, when you do some kind of a masking on your network part, it is a supernetting. Again, when you do masking on your HID part, it is a subnetting. HID is telling you zeros to ones and supernetting is telling you 1 to zeros. So from this, I could able to say that number of HIDs after doing a supernetting, I can get that number of HIDs is nothing but as your HID length is increased. Now HID length is increased, which is of 10 bits. I can say that 2 power 10 minus 2 HIDs. So you are going to get 1022 HIDs. Your motto is got satisfied. So you may get a doubt how many bits I can able to borrow, how long I can able to do this kind of super netting. You can able to do up to the second octet. So let me do now. I'm doing class C mask. Why I'm giving class C mask? Because supernetting is nothing only for small C networks only. Because already class A can give you 2 power 24 minus 2 HIDs. Class B can give you 2 power 16 minus 2 HIDs. But the poor class C can give you only 2 power A. So we want to change its lower figure to higher figure. That's why we mainly used in classful IP addressing, especially to class C network. Please remember this point, friends. We are doing supernetting in class C networks in the classful IP addressing. Let me give another example. I'm doing a supernetting now. So this supernetting example is telling you that I'm doing some operations on class C, N1, network 1, 2, 3, 4, 5, 6, 7, 8, and there are 8 zeros are with me. With that 8 zeros, I could get only 256 HIDs. Now I want to enhance it. So I'm making to 0 here, 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 I'm making to 0 here. See that how I'm asking. And I'm borrowing once again. I borrowed once again. Now you listen carefully. Finally, once after doing this kind of a masking, what is your supernet mask? Your supernet mask is, friends, N. This is not disturbed. This is not disturbed. All the bits are completely manipulated. So you got 0 and you got 0, which is very equivalent to how many HIDs? 2 power 16 minus 2 HIDs. So I made which mask now? Yes, class B mask. This is the class B mask. Understand carefully, friends. This is a class B mask I did just because we using with the class C network. Please understand carefully. This is the beauty of supernetting. From a class C network, I could able to borrow the bits from your network part, and you see that your masks are going to become, which is very equivalent to supernet masks. That is class B network I did from class C network. Now you can also do this. How long you can do? The class C subnet mask can also be equivalent to class A subnet mask. How? Let me show you now. So I'm doing one more example here. See that? I seen your class C mask is this. What is your class C mask? It is n dot n dot n dot h, but I performed in the class C itself. Now your class C supernet mask, your class C supernet mask, which is very equivalent to class B mask, because I borrowed 8 bits from your octet. So when you do borrowing, it is the concept of supernetting. Now in the next example, I want to say that how you can able to change your class C mask to class A mask. This example is talking like this. I say your class C mask. The class C mask is 255 and 255 and 255 and 8 zeros. So friends, I want to convert into class A mask. How? Just using a concept of what? Supernetting. By using a supernetting, I can able to reach to class B mask as well as I can able to reach to class A mask. Now what I am going to do, I am trying to borrow bits now from your NID. This is N, this is N, this is N, and these are all H. Now let us write 255. This you cannot disturb, and this is 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. This is your N, this is your N as per as class C network. Now there are 8 zeros are with you. This is your HID part. We are not going to disturb because our objective is to increase HID part only. Now here what is going to happen? I am masking as usually. So I masked this, this, 4, 5, 6, 7, 8. See, I am asking from right towards to left. Please understand carefully. Subnetting is a left towards to right, masking zeros to ones, and supernetting is a masking 1 to zeros from right to left, reverse, completely reverse. Now here I got 2 power 16 HIDs, which is equivalent to class B. Now I want to reach to 2 power 24 minus 2 HIDs. So I am making mask. So masking is happening 4, 5, 6, 7, 8 bus. Now you see friends, your new supernet mask. Your new supernet mask. This is a constant 255 and I made them to zeros now, which is a very equivalent to class A mask. See the beauty, how the class C is behaving like a class B and a class A because of just borrowing the bits from your network ID so that you got increased your host IDs. Now how many host IDs you can get from this? How many host IDs? How many host IDs? You know the answer. So 8 bits, 8 bits, 8 bit zeros are there. So 2 power 24 minus 2 HIDs are there, which is very equivalent to the class A. That's it. Your motto is satisfied. So my dear friends, again I am telling you, the class C can perform as like your class B and class A, not directly. It is only possible with the supernetting concept. So the class C can be reached to class B and class C also can be reached to class A just by taking the concept of supernetting. Okay friends, now I shown you how to do the masking. How to do the masking? Right towards to left, consecutive ones. You need to do consecutive zeros from right towards to left. Subnetting is zeros to ones. Supernetting is 1 to zeros. So consecutives required. Otherwise, it's not going to be called as a word supernetting. So what is the rule? The rule is consecutive masking from right to left. It is a better habit, friends. As I am doing in industry, this is the policy I am following. You also follow. And another rule is that what is the main approach of your supernetting? Simply masking NID part, NID part, from ones to zeros. And ones are going to be decreased and zeros are going to be increased. When zeros are going to be increased, your length of HID is increased so that number of host IDs are increased. And now, what is the advantage? And how many supernet blocks you are going to get if you do a concept of supernetting? So if I am doing supernetting, how many? This is very important question. First important question is number of HIDs. How many bits you borrowed? So here also, how many supernet blocks? How many supernet blocks? after masking. So now we need to analyze this. The solution is, please understand carefully. As usually, I am coming with a class C mask. The mask is telling you 255.255 dot. Let me do third octet in the binary, and there are 8 zeros. Now, when I mask the first MSB of your third octet, this is your third octet. When I made this one to 0, you got 1 bit supernetted. Please understand. This is 1 bit supernet. And when I do next one, so remaining ones only. When I do next one, 00, it is called 2-bit supernet. So I am doing 2-bit masking, and the remaining are ones. When I do 3-bit supernetting, then you got 000, 1, 2, 3, 4, 5. So this is how, this is a fixed, because host ID part we are not going to discuss. We are trying to do masking on NID 1 bit after 1 bit after 1 bit after 1 bit. And right now this is going to be fixed, because unless you do masking on your third octet, you cannot do masking on your second octet. So friends, you observe carefully. This is how one after another bit you need to do mask. After masking, your supernet mask is going to be changed. This is initially 255.255.255.0, and this after doing a masking you got 255.255.1 bit supernet masking. That means what, 7 bits are there with you. So you got 254.0. When you do next one, you performed a 2-bit supernet masking from right towards to left, then it is going to be 252.0. When you do the next one, so you got 255.248.0. So when you do 4-bit supernet, you are going to have 255.255. See that right 4 bits, right 4 bits are zeros, left 4 bits are ones. It is a 240.0. And next one 224.0. Next one 192.0. Next one 128.0. So this is how you're going to get a new supernet masks. So from this he is asking that how many supernet blocks are there. So this you can get easier answer. Number of supernet blocks. Now I'm releasing the answer. Please all of you take care. Number of supernet blocks. So number of supernet blocks are nothing but number of bits borrowed. Plus. So as many bits you borrowed, you are going to get those many supernet blocks. For example, I am saying class C mask 255.255. And I am doing 240.0. Now here what is going to happen? So you got something manipulated here. This is the N, this is the N, this is the N, this is H. So your network ID is being performed some masking. Instead of 255, it is given 240. Hence you see that how many supernet blocks. So how many supernet blocks are nothing but how many bits you supernetted. or how many bits you borrowed. So 240 is nothing but in binary 4 1 and 4 zeros. That means 4 ones you borrowed to mask 4 zeros. Therefore 4 bits are borrowed. So 2 power 4 is nothing but 16 supernet blocks. So what is the meaning of 16 supernet blocks? Which means 16 small classes are combined. Small class C networks are combined. 16 small class C networks are combined. Now, next question, what are the supernet blocks? So we find number of HIDs. We also find number of supernet blocks. Now we are going to find what are the supernet blocks. So before learning what are the supernet blocks, let us take one more example here. I am saying let class C mask. This is given. He is asking how many supernet blocks. So my dear friends, the solution is very simple. How many bits you borrowed? You write 192 in binary. 1160. Plus you got answer. So number of supernet blocks are 2 power 6, which is nothing but 64 supernet blocks. And how many HIDs are there? How many HIDs? The answer is 2 power 6 minus 2. And before you say 2 power 6, and we also got here 8-bit position, so 2 power 8. So this is altogether 2 power 14 minus 2, because this is our HID part. Now the next question, finding supernet IDs, also called what are supernet blocks? The solution is, observe carefully. So I'm doing now, this time I'm going to present you IP address. I say class C I'm taking 192.10.100.0, and I'm giving you the mask 255.255.252.0. Now you see, he is asking if it is supernetted, what are the supernet blocks are there? So observe n, n, and this n is manipulated, this h is a constant. So this is our target. Now you see that, take your 252, write in binary 00. So this is as usually h part, this is a n, this is a n, and this n is manipulated, and this 0, 1, 2, 3, 4, 5, 6, 7, 8. Now you observe, I borrowed 2 bits. So identify them. And 2 power 2, you are going to get 4 supernet blocks. So write 2-bit formation now. So this is your gap. Remaining are not being used for supernetting, and remaining bits we are not performed any kind of masking. Now you need to write 0001. 2-bit subnetting, 2-bit supernetting. I am writing combinations 01, 10, 11. For every combination, you are having same length the other side. Okay, friends, observe carefully. So I am pulling you the number of supernets as well as what are the supernet IDs. So you got finally this is a one supernet number, this is a one supernet number, this is one supernet number, this is one supernet number. So one of your supernet is this one, and one of your supernet is 0, and next your supernet is this one, next your supernet is this one, next your supernet is this one. So your first supernet is 0, then second supernet is a 1, and the second supernet is a 2, and the third supernet is a what? 3. 1 is nothing but 3. But you understand. So we are not disturbed any kind of these bits, and we not disturbed this NID, and we not disturbed this NID. Now you want to write your supernet blocks, take your IP, because supernet ID or subnet ID you are going to get after writing your IP address only. So I am taking your IP address now. Your IP address is 192.10.100.0. Write this because this octet is being manipulated. This is a fixed. This is a fixed. I'm not going to touch because no manipulation is done on second octet and first octet. Only manipulation is done on third octet. Our intention is also the last 2 bits of your third octet. And this is a constant. All 4 combination this is a fixed. And leftmost 2 octets also fixed. And the right leftmost 2 octets, that is 192.10 because no masking happened on them, and 192.10 no masking happened on them, and 192.10 no masking happened on that. Now listen carefully. This 100 is disturbed because on third octet only you performed 2-bit supernetting from right to left. Therefore, you write your 100 in binary, that is 0 1 1 0 0 1 0. So this is completely n, this is completely n, this is up to here it is n only. Please understand, up to here it is n, and this is completely h. And now we manipulated on third octet to mask from 1 to zeros. So 2-bit supernetting happened. This is supernetting, this is also supernetting. Now I am going to write 2-bit combination on them. Now this is fixed. 011001 because it is NID part. 011001, this is NID part. Next 011001, this is NID part. Now friends, starts with 00, next combination 01, next combination 10, 2-bit manipulation I am doing because 2-bit are being performed masking, and next is 11, same like the previous. So first block is 100, second block is next one, third block is next one, third block is next one. Here also you are going to get consecutive blocks you are going to get. So the first block number, first supernet block, I'm going to write now. This is your first one. This is second supernet. This is third supernet. This is fourth supernet. So your first supernet block 192.10 point, no masking done. So now you read completely. The value of this is 100.0. Next one is one manipulation 101. Continuous you are going to get. You don't bother about that because consecutively we perform the masking. Next one 102. Next one 103. So 0, 1, 2, 3 starts with 100. So this is 0, this is 0, this is 0, this is a 192.10, and this is a 192.10, and this is a 192.10. This is your second supernet block. This is your third supernet block. This is your fourth supernet block. Okay friends, now you see starting block number and ending block number we want to identify. What is your starting block number? This is only the first IP address is your starting block number. Your last IP address is your ending block number. So I can able to assign the IP addresses. So almost I got 1024 IP addresses. Why? This can give you 256. This can give you 256. This can give you 256. And this can give you 256. So almost all I got 1024 HIDs. Okay friends, now what is your starting number and what is your ending number? Here we are going to consume only two host IDs. That is, one is a starting block number and another one is ending block number. But subnetting is not like that. Every subnet is going to waste two host IDs. That's why we seen that the reduction of IP addresses there. But here we are trying to consume as many smaller networks you combine, those many you are trying to save, because all together we are spending only -2. One is your starting block number, the other one your supernet block address. The first one is supernet ID, and the last one, what is the last one? 192.10.103. The last address is 255. This is your supernet broadcast address. Now let me write. So what are the pool of the addresses you can write from the above question? The pool of the addresses I can write like this. Now IP address assignment. Because already we see that the supernetting is done. Now IP addresses are allocation. So 192 point and the second octet is 1000. So 10.100.0. We are not going to use 0 because it is a supernet ID. First supernet ID. So we are not going to use it. And the second IP address which is useful, you can start with 100. 1, it is okay. Then 2, it is okay. How long? How long? You can use consume. You can use 100.255. It is done. So all your 256 HIDs are being consumed here. Still I have 3 more 256 IDs. So still I can continue. So 192 point, 10 point, 100 point. So 100 is already done. Now we are trying to do with 101. 101.0. This is a valid. How long you can do? So 192 point, 10 point, 101.255. So in that block I can consume almost all 256 HIDs I have used. All are valid. Only one is reserved. This one is only reserved. Now third network is there. What is that? 192.10.102. Start with 0. This is valid. How long you can do? So 192.10.102.255. Up to this you can do. So this is done. 2 power 8 HIDs. Now fourth one is there. That is 192.10.103.02. How long you can do? 192.10.102.254. These are all valid. The last number you did is reserved. So 192.10.103.255 you cannot use. That's it, my friends. Only two. As many networks you combine, I don't mind. I'm going to see that the starting block number, ending block number is going to be reserved. The remaining all IPs you can able to use it. Now, one more example I'm telling you. I say this is my IP in class C 192.168.100.100. It is given a mask 255.255, and this is given 248 and 0. So here I performed as per as class C concerned because supernetting can be performed in class C. So I say that this is your HID part. Now this is been masked. So when this is masked, you see that what is the value of your 248. This is your value of 248. Now which means that 3 bits are manipulated. 3-bit subnetting is done, which starts with 100. Now let me write the 3-bit manipulation 001 and dot 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 111. So this is your still there are 5 bits for networks are there. Now for everything we are having 8-bit zeros. And so on. This is how quickly you can do. So starting number is 100. Next 101. It goes to, now what are your supernet blocks? I can write easily. 192.168.100.0. Next 101. Consecutively will get 101. This is a 1, 2, 3, 4, 5, 6. This is 7. So dot dot we go. 107. What is the last number? 255. So that's it, friends. These are the blocks you got. 2 power 3. You are going to get 7 supernet blocks. Start with 100, end with 101. So 100 to 107. It is 8 supernet blocks. As you borrowed 3 bits, then it is a 2 power 3 is nothing but 8 supernet blocks. And now, my another question. So if I am saying something like this, 192.168.98.0 and 255.255 point, and I'm saying 248.0. So when I say that this is a class C, now you know the formation of class C triple NH, but in this triple N, the HID of your subnet mask is manipulated to 248. Just write 248 in binary. So 1, 2, 3, 4, 5 and 3 bits manipulated. So 3 bits are now supernetted only. So 2 power 3 you got 8 supernet blocks. Now my question is it your does 192.168.98.0 is first supernet block. Is the first supernet block? Question number. Now we will say answer no. Why we say answer no? It is not your first supernet block. It may be one of your middle of the block only. How I said, how can we derive such kind of equation? How can you derive? These are the very good question. Now this one, is this your first block ID? As like your previous question, what is the previous question? I started with 100. Is this your first block ID? Yes, of course. This is my first block ID. I started with 100 and consecutively it goes to up to 107. So 100 to 107, there are 8 supernet blocks that starts with 100 and ends with 107. But here, can I say that? Can I start with 98 is your starting block number, or is asking, is it your supernet ID? That's the second question. Does 192.168.98.0 is supernet ID? Question mark. We will say no. It may be middle of your supernet number. It's not your starting block number. How can we do this? I'm going to tell you. Write your given IP in binary. 192, 168 and 98 and 0. So 0 means 8 zeros. Because no manipulation is done on that, only manipulation is performed on this only. This is n and this is n. So now write your 98 in binary. What is 98 binary, my dear friends? 0, 110, 96, 1, 2, 3, 4 and 0. Now you see, we performed in the mask 248. 248 means this is 3 bits supernetted. So leave the 3 bits gap there. This is your HID and these are all your NID only up to this part. These are all your NID. Now see, 3-bit combination you need to write as they are supernetted. So your 3-bit combination starts from 0, 000, but your combination starts from 010. That means it's not your original supernet number. It is one of the middle supernet number only. It may be one of your supernet IP address, or it may be one of your IP address. It's not your block number. Why? So 3-bit manipulation in the sense is supposed to start from 000. So I'm writing 000, 001, 010, 011, 100, 101, 110, 111. So 8 blocks I got. So what is the first one? If I am making 000, what is the value? It is, let me write now. It is 192.168.01100. And now I am writing 3-bit combination. What is the value? Now you know what is the value. It is 192.168.96. It is. Please observe. It is a what? 96. So starting off your block number is a 96, and next one consecutively you will get 97 and 98 and 99 and so on. 96 plus 8, 104. So minus 1, it is a 103.0. These are your supernet blocks. So my dear friends, that's why I said it is not your first block number. Why? It is not started with the combination 0. It is one of your middle number only. So your starting block number is this according to given IP and according to given supernet manipulation. So there is a shortcut to that. What is the shortcut? So same example I am taking 192.168.98.0. And the mask is given as, it all depends on mask only. Now we know that 248 can be written 000. That means 3 bits are borrowed. You know how to write 3-bit combination, and the last combination is 1 111 dot 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 dot. So 111, total 8 combination you are going to get. Now this 98 write in binary. Now I'm releasing the shortcut now. N N H. Indeed, some bits are N, some bits are H. Please understand, because 248 it is manipulated N N H H. This is not completely H. There are some bits for N also there. Now listen. The given mask is 255, 255, 248.0. Now you see this consists of some N and H. We have written like this. These 5 bits are for N. The rest of the bits are subnetted, which is meant for HID only. So write this given IP in binary. Now I'm going to find a supernet ID. How to derive supernet ID and a supernet broadcast address. Now I'm writing 192, no manipulation, so it is a fixed. It is also fixed. Last octet is also fixed. Don't worry. Now this is the manipulation. Write in binary 0110 0010. This is a 98 binary, and I said that this is a network, this is also network, and 5 bits are networks. These are all your network ID only, and the remaining we got supernetted bits, and we got this is HID position. So take the gap. These are the bits are being manipulated. So you want to get the supernet ID. You're supposed to make them all the HID positions to zeros only. So now 0 0 0, this is already in zeros only. You want me to write? I will write. This is your first supernet block or supernet ID, which means 192.168 and this value 01100. Now you want supernet broadcast address SBA. I said this is now completely HID format only. From here to there it is HID. So make HID part 2 once. Bus, you got remaining as it is, you brought them. Now friends, what is your value, final value? Your supernet ID we got as like the previous only. What is your supernet ID? Start with 96, end with 103. We also get the same using a shortcut. Start with 192.168. This is your starting number. 96.02 last number. What is the last number? That is supernet broadcast address, which is 192.168. What is this value? 96 plus 7. It is a 103. What is the last value? 255. So one is a supernet ID we got, and the other one supernet broadcast ID we got. So well friends, we do one more problem. So 200.200.130.130. 0. Now I'm using a shortcut. He is asking find Supernet ID and Supernet broadcast address, or starting block number and ending block number. You first to understand this is very important. 240 is 4 ones. There are 4 zeros. That means these are NID and these are HID. That means I am doing 4-bit manipulation now. So your 200 is a fixed, this is a fixed, this is a fixed. You write them. We are not performed any manipulation on that. It is 0. Now 130 is being changed. 130 means 128 is on and the remaining off and 10. Now you performed 4 bits supernetting. So leave 4-bit gap. These are all completely now your NID only. So write into decimal. So 200.200.1000 and host ID bits are zeros now. And broadcast address we want. So what is the SuperNet broadcast address? It is a 200.200.1000 and 1234 1234567 our answer. We achieved it. So what is your SuperNet ID? 128.0 and what is your SuperNet broadcast address? 128 plus 15. 128 plus 15 is your SuperNet broadcast address. So let me write now. Your final answer is, I am writing in a decimal, 200.200. Starting number 128.0, ending number 200.200. So 128 plus 15, 143 point, all 5, all 8s, 255. Well friends, so your SuperNet blocks from this 128 is your starting block, 129, 130 you will get consecutively 140, 151, 142, 142, 143. Last number is 143. You have to stop it there. So you got 8 SuperNet blocks. Eight SuperNet blocks which starts with 200, 200, 128.0. Next 129, 130, 131, last one 143. These are your total 16 block numbers. Because 2 power 4 you are going to get 16 blocks. There are certain rules to do supernetting. So what are the rules? Rules like CIDR only. Rules for supernetting. Rule number 1, IP addresses, IP blocks must be consecutive. IP blocks must be consecutive. This is the first important point. Second important point is that all together block sizes. That means what? Size of HIDs or size of supernet must be represented in log form. Log form. And the third rule is that starting address, that means supernet ID or first address, must evenly divisible by size of supernet block. So these are the 3 important rules you need to follow while doing supernetting. And now for example I will tell you how the rules are going to be violated so that we are unable to do supernetting. I'm saying four small C networks are combined together to supernet. Is it possible or not? 192.168.100.0. This is 200.200.100.0. This is 200.200.100.1. This is 192.168.100.1. My question is, can we aggregate them? Can we aggregate them? Our answer is no. Why no? Because your IP blocks are not consecutive. IP blocks are not consecutive. So we are failed in rule number 1. This is a rule number 1 failed. And rule number 2, if you consider, I am saying first one 192.168.0.1, 192.168.0.3, 192.168.0.5. This is also what happened. Rule number 1 failed. Now I will give you one example. Rule number 1, I will make it satisfy 192.168.0.1, 192.168.0.2, 192.168.0.3. Now here, this is also wrong. Why? Because now my question is this eligible? Can we aggregate them? Can we aggregate them? The answer is no. Why? Because they all belongs to same class IPs only. That means you have not performed any kind of a masking over here. This is also 0 and this is also 0 and this is also 0. You have not performed any masking on this. Now I'm doing rule number 1 perfectly. So 192.168.0.01 network, 192.168.1.0 another network, and now 192.168.2.0 another network, 192.168.3.0 another network, and 192.168.4.0 another network. Can we combine? Rule number 1 satisfied? Yes. Rule number 2 is satisfied? No. Why? 1, 2, 3, 4, 5. 5 blocks. The 5 blocks you cannot able to put it in the form of what? Log 2. Bus. It's gone. Therefore, this is not a supernetting aggregation. So it's supposed to be represented in the form of 2 powers. So I'm taking now 192.168.0.0, 192.168.1.0. See that I am asking this now. 2.0, 3.0. My question is, can we aggregate them? We will say yes, perfectly. Why? Rule number 1, consecutive satisfied. Rule number 2, the 4 blocks can be represented in the form of 2 powers 2. 4 blocks I can able to represent in the form of 2, which means what? You performed 2-bit supernetting. Please understand carefully. And rule number 3, the first IP address, that means 0.0, can evenly divisible by your size of your block. Otherwise, in the first block number, the last 2 bits are supposed to be, because you performed 2-bit supernetting, the last 2 bits are supposed to be what? Zeros. Yes. In third octet, especially in third octet, the last two bits are zeros. Hence rule number 3 is also what? Satisfied. Now I can combine. After combining, you got super network. After combining, the supernet address representation is, take your IP 192.168.0.0. This is the first one, slash 255.255. So you performed a 2-bit masking, right? Because a 2-bit supernet you perform. 2-bit means, let me write in binary. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are supernetted position. We performed masking. Instead of ones, they are zeros. So what is your final value? So 192.168.0.0 slash 255.255.252.0. Finally, you got the answer, friends. So this is how you need to do. And see that some of the examples you carry on your side. I say 200 point, 100 point, 100 point, 0 slash 255.255.240.0. Can we combine or not? These are the questions. So that means, can we combine or not, in the sense, is this eligible for a supernet? Is this eligible? Or you can write, let me write the question carefully now. What is supernet ID, comma, supernet broadcast address, and number of supernets, and number of HIDs? These are the questions you are going to get. And another task I am going to give you. The task is 192.168.0.0. Next, 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0. So everywhere these are given. Now you decide that what is the supernet mask of this representation. After combining, what is supernet mask? So well, friends, so this is how you need to do, or you can carry forward a concept called supernetting. So the first example I mentioned that what is the supernet ID, what is the supernet broadcast address, and number of supernet blocks and number of HIDs. So I already trained you, number of supernets are nothing but number of bits you borrowed from your third octet. And you look at the next one. I have given a few range of blocks, and these are range of blocks only. Can we able to combine them? These are the range of small class C networks, 4, 5, 6, 7, and 8. Because I started with 0 and I ended up with 7, 0 to 7, it's nothing but 8. Now he is telling you, can we able to aggregate them? This is the first question. What is the first question? Can we aggregate them? If you can aggregate them, then what is the supernet mask after aggregation? So I already did here. Please see. These are the pool of the blocks I have given. Can we aggregate them? This is our first question. Yes, we can. So how I aggregated? So 2-bit supernetted I perform because you got 4 supernet blocks are given. So that means what? 4 supernet blocks you got means what? 2 power 2. So 2-bit supernetting I did. After performing 2-bit supernetting, this is your NID, this is your NID, and here also they are our NIDs, and this part is manipulated, this part is manipulated. So you got these many bits. Only these bits are manipulated from ones to zeros. Therefore, your new supernet mask, take your IP as it is, and 255 is a fixed, and 255 is a fixed. After manipulation, 2 zeros, so rest of the numbers are ones. It is nothing but 252 and 0. This is how you need to do the same example. What is that? 8 supernet blocks you got, that means 3 bits subnetted. So write the 3-bit supernet mask. 3-bit supernet mask is first 255, next 255, 3-bit supernetting, and last one is 0. That's only your new supernet mask. But before that, you see, can we aggregate them or not? Can we aggregate them or not? You need to use 3 rules. Please understand. Aggregation 3 rules I said. Please listen, aggregate 3 rules. These are the rules for aggregation. Understand, friends. So can we aggregate them or not? You have to observe that rule number 1, IP blocks must be consecutive. And rule number 2, the IP supernet blocks must be represented in the 2 powers. Rule number 3, the supernet ID, the starting number must be evenly divisible by the size of your block. So you observe that question, that can we do aggregation or not? So the IP blocks 0, 1, 2, 3, 4, 5, 6, 7, rule number 1 satisfied. Rule number 2, there are 8 blocks are given, 8 can be represented in 2 powers, rule number 2 also satisfied. Rule number 3, the starting number. So how many bits subnetted you performed? 3 bits. How many bits you performed supernetting? 3 bits supernetted. Why? Because you got 8 blocks. When you got 8 blocks, 2 power 3 is nothing but 8 only. That means 3 bits are subnetted here. That means in this octet, because this is the manipulated, in this octet 3, you see that the first IP address, the last 3 bits must be zeros. If the first IP address, that means what? First block, IP address, third octet, if the last 3 bits are zeros, yes, it's a perfect. The rule number 3 is also satisfied. In that you can say that 0 means what? All zeros, so last bit 3 bits are zeros. Now you write your supernet mask using that. So 2 tasks I have given to you. Please see that. I want to find in this task, directly I have given find these questions. And second one I am asking indirectly. I have given the range of the blocks. You see that can they able to aggregate them or not? If they can aggregate, rule number 1, rule number 2, rule number 3, then you start giving a what? Supernet mask. Okay, friends. Now the supernetting got completed. In tomorrow's schedule, this is a tomorrow's schedule on YouTube. Your tomorrow's schedule is MCQs, multiple choice questions on subnetting. Don't miss, my dear friends. This is your tomorrow's schedule. Okay. And what about today's schedule? Today already we completed one of the lecture. Your next today's schedule program is 2 varieties. 1. We are having a quiz part 3. Quiz part 3 is there because already we performed last session 2 and before session 1. Quiz part 3 is there. So before attempting this quiz part 3, please learn whatever the IP addressing lectures I put it in your YouTube. Let's crack GATE CSE. Please follow those lectures and follow quiz 2 on Unacademy learning app. This quiz is on Unacademy learning app only. download this app, then you can able to do the quiz sessions. I'm going to discuss in quiz 2 I discussed 30 questions. In quiz 1 I discussed around 40 questions. Please download that app and watch those two quizzes so that you will have a good grip on quizzes. And this is your today's session, the quiz session. The quiz timings are 4 p.m. to 5 p.m. This is a quiz timing. You're going to get the quiz only on Unacademy Learning app. And another program, that is 7 p.m. to 9 p.m. This is a very important program. Today onwards, the course structure is started. That is a DBMS plus course is started. The timings are 7 p.m. to 9 p.m. This course is only for the plus students only. Those who are premium students, that means what, those who are taken admission in an academy, then they could able to get this. So the subject is DBMS. This is only for what? Plus students only. Only for plus students. The timings are 7 p.m. to 9 p.m. So daily 2 hours class. The course name is a comprehensive course on database management system. So today I am going to discuss data model. Then after that schema design. Then after that ER model. Then after that SQL part 1. So this is the structure is being defined. Timings are 7 p.m. to 9 p.m. Don't miss these classes. Already those who are enrolled into Plus in an academy, please enroll into my course. If anybody not yet taken subscription in an academy, use my referral code to enjoy the session, because today is the starting session on database management system, which takes up to 60 hours. That means 30 sessions I am going to take. So don't miss this today's session. So if you not get admission in an academy so far, use my referral code. If you use my referral code, then you are going to get a maximized discount. So you will be enjoyed the discount, because your 1 year subscription is 22 odd, 2 year subscription is a 25 odd. If you use my referral code, you are going to get a maximized discount. That benefit is given by Unacademy. So my dear friends, if you not yet taken admission, immediately taken today itself using my referral code, then you will be tagged with me that you are going to listen all my lectures, whatever is happening in an academy. That's why use this referral code. Otherwise, you are going to be separated from my batch. And those who are already enrolled in Plus courses, those who already joined in Plus courses, just there is a button in my course icon, that is a comprehensive course on DBMS. Click on that and enroll. If you enroll, then you are tagged to my batch, those who already joined in Plus. Okay friends, so join in an academy, get Plus subscription using my referral code, and you can able to view all my lectures. Right now I'm starting DBMS, after that computer networks, after that operating system I'm going to start. Anyhow, so free lessons I'm sharing on YouTube. Our YouTube channel is Let's Crack GATE CSE. Please understand. So you also can thorough with those lectures. That is, our YouTube channel is Let's Crack GATE CSE. So there you get the subscribe. Then you're going to find my portal playlist. You're going to find in that playlist Srinivasrao. Find this name. Then you're going to find free subjects I already kept. So 30 lectures for database odd, operating system also 30 lectures I odd, and the computer networks right now I am doing. These are already there. So 30 sessions I kept. These are also 30 sessions, full syllabus I kept. And CN right now I am performing my 14th session. So please watch all my videos, operating system and computer networks and database. Give a positive comments as well as give a like. After watching it, please give a like friends, because like is going to give me a lot of encouragement and lot of claps to me. So therefore I can able to do much more work for other subjects apart from these three subjects. So this is about a YouTube program, and you see that our Plus on YouTube, this is on YouTube tomorrow schedule, don't miss. That is a questionnaire discussion, And this is for today's session, that is a quiz part 3 on an Academy student learning app. This is a free, but the 7 p.m. to 9 p.m. session is a paid course. So use my referral code, get the subscription and get the DBMS sessions. If you join after 5-6 days, you are going to miss the live session. Anyhow, recorded session will be available, but the live session you are going to miss. You cannot ask any questions to me. That's why today is a good day. Immediately take the subscription and enjoy the sessions of database management system. So as I am certified in database side as well as networking side as well as Red Hat Linux side, so I can able to 100% give you guarantee that you could able to success GATE program, because since my 17 years of experience, many 17 batches are went. So I trained many students, thousands of students are trained by me, and many are settled in topmost companies, and many of my students are completed their post graduation in IITs and IITs and central universities and triple IITs. So many of my students completed their post graduation in triple IITs Hyderabad. They are working fine in Amazon as a topmost position. So my dear friends, you also can be. So I can able to guide you in projects and related side, but provided that you're supposed to use my referral code, then only I can able to guide complete guidance. Thank you very much for watching my lectures. Please do like and as well as give a positive comment so that I can able to do a better lectures. And don't miss today's schedule, that is quiz on IP addressing part 3 and DBMS lecture on plus courses. Tomorrow as usually 6 a.m. This is as usually tomorrow as usually 6 a.m. YouTube schedule. So friends, we will meet in the next session, that is today 4 p.m. 5 p.m. session. We will meet in the quiz as well as 7 p.m. 9 p.m. DBMS plus course, and tomorrow YouTube session, that is 6 a.m. Thank you very much for watching. Stay tuned to Unacademy.